Hey YouTube, it's JP Dillon. Today we're looking at a mid-60s, about a 65 or 66 RCA model af-141w. This was a curbside find that my friend Gary sent me an email about. He says, hey, check this out. And turned out it was close enough that I could grab it on my lunch, so I did, along with a Zenith Chromacolor with a horizontal chassis, which we'll get to at a later date. This one's in pretty nice shape. It is an all-metal cabinet except for the front. This CRT escutcheon, fake vinyl. It's got the classic RCA Victor logo. New Vista all-channel. The back's kind of interesting too, which we'll get at here. The back is all plastic instead of metal like the last one we looked at. And obviously there were options for a remote and an external speaker. And you've got some interesting stuff here, like the sync stab, AGC, horizontal hold, vertical linearity, hold height, etc. And then you have the contrast wheel, which is a little bizarre placement, but okay. So this set's complete. It's not a rust bucket like the other one was, at least I hope not. I haven't opened it yet, but that's what we're going to do next. So let's get the back off and see how it looks inside. Well, this certainly does look very similar to the, what was it, the 147, 146, or whatever it was the other one was. Very similar. This one looks like it's a KCS 149. And I'm betting it uses a lot of those strange, funky tubes that the other one did. The chassis layout looks almost the same as the other one. Hopefully this one doesn't have a dead flyback like the other one does. But at least I know I have another complement of tubes for it if I need to, because I did scrap the other set. But before we go much further, let's check the CRT and see what condition the CRT's in. Alright, so out comes the Beltron. Let's bring the heater up. And let's see if we get anything. I remember the last time I did this, the adapter I was using was kind of finicky. So let me see if I can get the other adapter out that I know worked. Nothing? Really? There we go. 10 volts is starting to show something. Come on, wakey wakey. Yeah, you go down to 6 volts and there's just nothing. Look at that. Look at that dead-ass CRT. Oh boy. Yeah, if we go down to 5 volts, it's even better. Bye-bye emission. Yeah, 5 volts, there's just nothing. You might get a picture with that. It's going to look like garbage, though. And wouldn't you know it, this one uses the same damn CRT as the one that I scrapped that tested like new. But let's give this one a little bit of a love tap and see if it comes back. Because really, this is just kind of too sad to make a picture, in my opinion. So let's first let's see if the cleaning thing does it. Crank it up. About 10 volts. Nothing. No flicker, no nothing. Alright, let's go back down to 5 volts. And let's do Mr. Rejuvomatic. Ooh, look at that. Sparky Sparky. Let's crank it up. At 80 milliamperes, you're supposed to cut it off. It's almost like it's got a short, because there's no filament voltage right now, and there's still current flowing. There shouldn't be. Yikes. So with a dead filament, this thing is just baking away. Yeah, not good. We got our cleaning light though. That's better. Came back. Yeah, look at that. Came back pretty good. Now, without having the other one here to test for cutoff and stuff, I don't really know what the true condition of it is. But typically speaking, you can rejuvenate the cathode. The cathode will allow you to have a picture on the screen, but if the control grid's trash, then it ain't really going to make a great picture. It'll just make a watchable picture. If the control grid's trash and there's no cutoff, you're not going to see a whole lot. But let's go down to 5 volts and see how much it keeps emission there. Yeah, it came back okay. And it may be that I'll get the CR7000 out and we'll do a real CRT test on it to show what the life of the control grid is. And if it's good, then leave this one in here and I'll have the spare. And if it's not good, then we'll swap it out. But yeah, that's looking good so far. So let's get it on the dim bulb tester and see what it does. Alright, so we got our dim bulb tester hooked up. Let's see what she does. It's getting a little dimmer. Let's see if what's going on back here. No filaments lit yet. I don't expect these to get hot instantly. There's no dead shorts. Funny how on this one they have those chassis mounted rectifiers there. On the other one they were just hanging out in space somewhere down here on the terminal strip. So they cleaned it up a little bit. Woohoo. Alright, so I'm going to let this one bake a little bit. The bulb's getting dimmer in a slow fashion. Yeah, let's use our words. And then once I've given it a chance to bake a little bit, then we'll juice it and we'll see what's going to happen to it. I have no idea how long it's been sitting. So we'll find out. Maybe while I'm waiting, I'll spritz a couple of the pots that I have access to. I think we'll do these brightness and volume pots and stuff. Assuming I can get the straw to cooperate. And just turn it. And we'll do the volume pot. Why not? You know, this one seems to draw a little more current than the 146 did. Because I remember that that bulb would get a lot dimmer. Of course, that's not to say that there isn't something wrong with one of these guys. We just don't know yet. Clean that contrast pot. We'll just set that at midpoint. And then let's see. I think that's... Let's see. There's got to be something else here that I'm missing. Vertical hold or something. Nope. Those are your only two front controls there. The brightness and the volume, and then the contrast up top. And then you have your vertical and horizontal hold. Let's see. All that's accessible via this side. Bear with me a moment. I'm trying to do this single-handedly. I don't have a camera mount handy in here. Oh, you kidding me? It's another horizontal hold pot with a dead stop. Is this going to be like it was before with the other one? Pull this off of here. If I can be. Oh, it's got a little rubber retainer. Yeah, horizontal hold without a stop. Oh boy, oh boy. Vertical hold has a stop. Of course, here it may actually be designed that way because if we zoom in and we look at the pot. Come on. There we go. This one doesn't have the D10 for the stop punched in, whereas the vertical hold does. So maybe it's designed to be free spinning. Who knows? We still won't know if it works yet. Man, look at how crusty those pots are. Like, what happened? Did somebody like put a power drill in there and try to turn it? I'm getting filaments lighting finally. Yeah, that's kind of ugly. What's that? That's your vertical height and stuff. I should probably still clean those. Let me get a tool that hopefully won't disintegrate them further. Yeah, that should work. That's just so chewed up. I wonder what was happening there. Come on. That was turned at its extreme. This is a wire wound too, I could feel it. Fancy. Okay, let's clean this one. I'm inserting the cleaner at a vent hole, which I assume is part of the stop. Trying to do this with a wiggly, flaily little straw is difficult with one hand, so that too is at its extreme. So maybe we've got vertical output issues. I did save the vertical output transformer, I think, from the other one. Well, it's been quite a while, and that bulb has not gone down. And these are still all pretty ice cold. So I think it's time we juice this thing and see what happens. We got a filament lit down here, so it's getting current and stuff. Yeah, why not? If it flames out, it flames out. Alright, we bypass the bulb. Let's see what happens. No idea. Ooh! Do you hear that? We lost our B voltage. We had sound for a moment, and then it got real pissed off. Breaker's not tripped. It didn't go clicky. But it certainly stopped working, didn't it? Let's ohm out that breaker. Well, breaker seems to be okay. If I push it, it goes open. If I let go of it, it goes closed. Not sure if I like how sloppy this is in here. Obviously something got pissed off. Back to the dim bulb test. Let's see if anything changed. Oh yeah, something shorted. Something shorted. That's a hard short right there. Blammo. Cool. Alright, let's find out what. So oftentimes a way to figure out if your main filters are busted or not is to pull off your plate cap here because this comes direct from the B voltage, and sometimes you can take a look at this and see whether you've got a short or not, but it's not measuring that here, so that's probably not it. So let's go to our rectifiers over here. No. Yeah, the rectifier diodes themselves are not shorted. And we don't have a hard short through here. Of course, that's also disconcerting because I'm not getting any resistance to ground there either. So is the primary open? Don't know. We're not going to worry about that just yet. What we have to do is figure out if there's a short in one of these guys, and if yeah, anyways, yeah, it's going to require that we pull this thing out. Okay, so with the dim bulb blasting away there, we see like no B voltage activity because the bulb is absorbing everything, and then obviously that goes back down to filament voltage when I take the B plus out of circuit here. So yeah, let's turn this off momentarily and look at downstream. There's still voltage here. Got 2 volts there. And nothing. Oh no, we got something here. Okay, so this is bleeding down. If there was a dead short here, it would definitely not bleed down. So we got probably something on the low side of a resistor that's shorted, that's just drawing a whole bunch of current. Because right on the low side of the breaker, I'm not getting a short circuit. So, okay, let's pull this stuff out. Okay, so we got the chassis folded back here. Let's see if we can spot anything obvious. This doubler was replaced. This has some nice shiny solder on it, and it looks like it's failed. You can see it, I don't know, maybe you can't see it, but back here in the corner you see that powdery stuff. That's pissing electrolyte, so not good. Let's see here. Come to this guy. We got 11K, 700 ohms, 800 ohms. Wait, 800 ohms? What? No, 600K. So, all right, let's come over here. La-di-da. 600K, 600K, 1K. That's a little low. 798 ohms. I'm not saying that that's the failure, but that seems low to me because the rest of this stuff is like super high. And then you've got this nice little melted piece of wire here. I don't know if you can see that. It'll focus on it. Yeah, so this chunk of wire here is nice and melty. But obviously, no sign of death. Let's clip onto the doubler by itself. And let's see what we get here, because this shouldn't be peeing. And that's a replacement part, too. Okay, so there you go. Doubler shorted. So if we go from here, which is the negative terminal on the doubler, to the center terminal here, we get a dead short. And that's what's pissed off. So let's go ahead and clip this out, take it out of the socket and put a replacement in there, and then very likely it will power up. So here's our shorted doubler cap, 160 to 250. Not happy. So I took two 100s at 450, which is what I had, paralleled them up, then soldered them up. I'll put some high temperature glue there to hold them, and then maybe we'll deal with that wiring and stuff later. Actually, it's not, the insulation's not compromised, it just looks scary because it's just a blob of goo on there. Yeah, it's just a blob of goo. And that capacitor there was obviously replaced, and some soldering was done on that thing, kind of crappy. So yeah, this is another wonderful nightmare. So anyway, let's get it back together and see if it fires up. Okay, so we got the chassis all buttoned back up, everything back in here. Here's my fancy doubler configuration. It's just two caps paralleled and wired up like the doubler would be. And we're going to stick it on the dim bulb tester just to make sure that there's still no remaining short. I don't think there will be, but let's try that first. Yeah, it starts out medium brightness and then kind of calms down like it was doing before. So, safe to say that it's probably safe enough to power up, so let's just bypass that. Okay, so here's the smoke test. Sound. Hey, look at that. We got some fold over here. Looks like that CRT came back okay. Okay. This is good. This is very good. It's sharp. We got some linearity problems here. You can see the compression, or maybe you can't. Anyways. Oh yeah. Looks good. Let's get a test pattern generator on it. Get it up on the reel bench. Get the damn camera to focus. Really? Really? Alright. Okay, so here we are up on the big bench. Let's see. Can't remember if that thing's on channel 4 or channel 3. A little test pattern generator. I think it's on 4. Alright, so we obviously have some vertical issues. Tuner's super touchy. There we go, got something. AGC is pretty wonky though. We got some massive nonlinearity here. Yeah, it's pretty ugly. But it's working. It is working, and I'm sorry if you're getting this Blanky McBlankface stuff going on here. That's a little better. Okay, so we got vertical linearity. We have vertical height. So let's see if we can fix this pattern. That's better, but there's a lot of overscan. Okay, we're getting there. You have to adjust the centering rings on the CRT. And we got some twitch, probably from old capacitors that are beginning to reform. Let's see if we can move this up a little bit without shocking the shit out of myself. That does nothing. Here we go. Notice that it was like shifted way down. We still got some non-linearity issues there. A little bit of compression at the top. That could be a waveform distortion. That could be a whole bunch of stuff. Contrast control is just so touchy. Look at that smear too when you get rid of the video signal. That's a little better. Pattern's looking better. So this one's in a lot better shape than that other rust bucket thing was, wasn't it? Now you can see I've got a little bit of bowing distortion, and that could have to do with the centering of the beam. So let's see if I recenter it to where it was. I really need a proper pattern, which I don't have with this set. Look at that, dashes. That's damper failure right there. Yeah, we're getting breakdown of the damper failure. Arky sparkies and stuff like that. So I need to get into the tubes that I harvested from the other one and replace that damper before it gets too heinous. So this one needs tubes, and the bowing's gone down a little bit now that I've shifted that. But you can see it's breaking up, it's getting worse. So before I kill this thing, what we're going to do is go into the tube storage, pull the ones that I got from the other set. We'll replace the damper, and we'll check the remaining tubes. But we're off to a good start with this one, better than the last set. But usually when you see those little dashes and stuff on the screen, it's damper breakdown or horizontal output breakdown, usually damper. But yeah, so I hope you guys watched this or enjoyed this episode. We're going to get into part 2 where we change out the appropriate tubes, and hopefully that will clear up the dashes on the screen and the pattern breakup. But out of curiosity, let's yank that damper and test it. Now they usually test okay on the tester, and it's an internal breakdown where things start to arc and spark. But out of curiosity, let's just check it in a couple of crucial tubes in the sweep section. Alright, so probably troubling is that when I pulled the damper out, and we just run this set like literally moments ago, it did not, it wasn't hot. I can still hold this. It's very warm, but it's not hot, so it's like not conducting properly maybe, because usually the dampers get pretty toasty. They got a lot of current and a lot of voltage, a lot of watts. So this one is a replacement. It's got the newer RCA logo on it. I don't know if you can see that well enough. It's got the newer RCA logo, so it is a replacement. There's no identifier on it. I don't know if somebody got overzealous with cleaning or what, but let me just check the tube chart real quick and then set up the tester for it. According to the chart, it's going to be a 6AY3. Okay, so socket 20, 14 on the plate. Let's go ahead and move the stool over so I don't tip the tester over. That would be fun. And this is just a big fat diode. This will probably, yeah, see, it tests okay in circuit, or out of circuit there, but under load is when you have issues. So I think substitution is going to be the only way to validate whether the damper's at fault for that or not. So let's just stick this back in here for a placekeeper, but I'm definitely considering replacing that. And then the horizontal output is a 6 JB6, like the other one was, I think. So let's come over here, JL, JK, JB. That's going to be socket 13. And we'll plug the plate cap in here. And I really need to get a better top cap connection for these. Plate's at 60. Wait for it to warm up and we'll see what happens. And we could also have a funky high voltage rectifier too. I mean, all that's possible. But you check the crucial sweep stuff, and if that's okay, like that's passable. But again, it's not really doing its duty. It's just on a mutual conductance tester, so it's not really going to give an accurate portrayal as to the duty ability of this tube. So let's pull a high voltage rectifier just to be sure. And let me get an appropriate tool and stuff for that. And unlike the other one, which has a keeper, this one just pops open. So they corrected that problem. And you got some minor drippings there, which is what you'd think for something about this age. But it's not burnt. It's not messed up. The core isn't loose. Take the top cap off of here, hopefully without destroying it. All right. So here's a 1B3. That looks pretty original. It was obviously working because, well, we got a picture. And if the high voltage rectifier isn't working, then it's probably not going to make a picture right at the beginning here. Okay, so socket 15, 34 on the plate. And obviously we got to use the Y. 34, I don't know, it's like, why not just round up to 35? Is there some sort of like scary bit of accuracy? You got to use 34, man. 35's too much. It's going to throw off the entire test. Yeah, so let's see. Where did that test lead go? There it is. And let me put this back on the holder. Yeah, let's see what this... because this is too fat. Wow, really? Really? Look at that. That thing just barely registers. Yeah. Plate 34, socket 15. That thing is just barely alive. But it made a picture, and a bright one at that. It wasn't blooming or anything. That's amazing. So maybe it's actually this breaking down. I mean, we'll grab the other ones just to be sure. But, yeah, that's, wow. So that's the original 1B3 that's about gone. About gone. I wonder if I have one of these kicking around. I don't think I do. Let me look real quick. And no, unfortunately, going through my stash of stuff, I don't have a 1B3 here. I've got 3A3s, but that ain't going to work. So, yeah, shame on me for stashing away all those tubes I harvested from the other set. But in any case, this is so far looking good. I mean, really, this could be the reason why we're we're getting a little hash and arcing because it's barely conducting, and that could just be its death throes. Or it could be the dampers breaking down, or it could be the horizontal outs breaking down. But I need to go back to storage and get the tubes that I put away there. And pop those in there and see if that gets rid of the nasty stuff on the screen. Because obviously we're getting waveform breakdown, and that could be any three of those tubes or something else. But so far, it's in much better shape than the last New Vista one we picked up was. So, yeah. In any case, when I grab the tubes, we'll do part 2. And we'll see if things improve. And hopefully, we can just clean this thing up and give it a go. So thanks for watching the video, guys. More stuff to come.